All right, thanks for checking this video out. Wanted to take a few minutes here and kind of walk you through all the Home Assistant ESP stuff I've been up to lately. This is a culmination of things probably over the last 3 years that I've been putting together. But anyway, this is the main mechanical dashboard for the house. And I want to walk through it kind of section by section, high level, and then I'll throw in some YouTube shorts at a later date, kind of digging into the details of where this data is coming from and how it ultimately gets here. So weather, pretty straightforward. I have a BME 680 series sensor that's sitting outside, obviously in the shade, attached to what I call my North Pole controller. North Pole just because it's a pole, it's on the north end of the property. But anyway, that's providing relative humidity, dew point, pressure, air quality, and then there is a separate luminance sensor in there that's measuring foot candles, and I use that for various automations, controlling outside lighting and so forth. And then this is just logic here that tells you what the actual pressure is currently doing, rising or falling. Up here, this is an MQTT RTL SDR integration that actually captures and decodes the wind speed data that's coming out of my Accurite sensor. That basically that's all I use that for anymore. And the batteries are totally dead and it's way up in a tree, and I haven't drug out the ladder to get it out of there and change batteries. But normally that would be coming in here over 433 megahertz. Jump back to temperatures. This is actually a Dallas temperature probe, and it's mounted right next to this guy, also in the shade, but the Dallas probes tend to be more accurate for OA measurement compared to the BMEs, so that's what's going on right there. Jumping down here, we have pool water temperature. This is, again, a Dallas sensor within a stainless steel probe well that is in one of the ports of a three-way T on the return line of my pool pump. With some thermal goo in there as well for a good heat transfer, but it's directly in the stream of water. This updates only when the pool pump here is running, which is controlled and scheduled through Home Assistant here. That ESP controller actually has a contactor that it pulls in to start or stop that pump, which also provides the status. This temperature updates only 30 seconds after the pump has started, and then every 2 minutes after that. So on the times when the pump is scheduled to be off, this will not update. It'll hold its current temperature. Otherwise, you get the probe, in still water, just baking there out in the sun. You get all kinds of weird stuff in your history. There is a pressure transducer on the filter output pressure. That's here, and it's reading as well. That goes into ADS 1115 analog to digital converter that goes into the same ESP controller that's running this pool setup here. This filter delta just is the delta from a starting point, which I think is 12 psi, in terms of where the filter starts at after a fresh backwash. But again, this is all controlled and scheduled through Home Assistant and helpers and automations and so forth. Jumping over to well water. This is my water storage tank. It's a 2,200 gallon tank. There is an ultrasonic distance probe that I built that is attached to the lid facing straight down, and it measures the distance from the top of the water, from the water surface up to that probe, and then calculates the water tank level, the tank volume, and then I have a calculation in there that resets at midnight. So as the tank gets lower during the day, it takes the delta of the water being used and totalizes that for each 24-hour period. So this resets at midnight every night. House pressure, this is between the booster pump that pulls from the storage tank and the pressure tank. Here's the booster pump run history. Obviously, if something's going, lawn irrigation or something's on, you'll see a lot greater history, but these are just your pump run cycles each time it rebuilds pressure in that booster tank. Here's a pump status. This comes from a CT mounted on that pump. This is just a calculation that shows the last time it actually ran, and then this is a totalization of those cycles. Down here is the actual deep well pump. This is a status right here, but there is also control of this through scheduling in Home Assistant. I can enable and disable it. At present, this pump is scheduled to run between midnight and 5 a.m. With the actual float in the pump. So basically I give it an enable command and tell it, hey, if the float is down and you need to run, you can run. Otherwise, I hold it out with a relay using the schedule here. And then it just again writes the last time that pump was filled and the total cycle, or the last time the tank was filled and the total cycles for that pump as well. This MTS 300 is a Meross open source thermostat. I like it because it kind of gives you access to a lot of the stuff that all the, Ecobees and Nests and Sensi's, and I've tried most of them, and the integrations are meh, so. Um, but this one I tend to be pretty happy with. It allows a direct MQTT integration, or maybe I think it's a Matter integration. On that HVAC system, I also have added supply air temp, supply air humidity, return air temp, and return air humidity. And then this is just the fan for circulation as well. So wood stove catalyst here. I've got a hybrid wood stove. It's a Rockport. Yes, a Lopi Rockport stove. And because it's a catalyst stove, it actually has a K-type temperature probe in the catalyst itself. And this runs back to a Max 136A5, whatever board that is that you attach a K-type probe sensor to. That goes to that, which ultimately connects back to an ESP32. That I also use that ESP for Bluetooth proxy for the door locks that I use throughout the house, or I use the BLE protocol that Yale has. But anyway, this K-type probe sensor in my wood stove catalyst, the last 3 years in a row, every time we get a close thunderstorm in the spring, and there's a close lightning strike, it just zaps that K-type interface that reads the probe. So I've had to replace that. And I've tried grounding. I've got filter capacitors on it. You name it, I've got it all there. And I just haven't had a chance to fix that yet because it's summer and I don't use I don't use the wood stove during the summer months. Anyway, jumping over here to energy. This is my local power provider. This line voltage, battery, UPS charge, and runtime calculation, it's actually coming directly out of a APC standard backup unit. It's using the NUT, Network Utilities Integration, in Home Assistant to pull this data live out of there. But if I wanted to see what the incoming power is from my provider, it's all right there. Propane, this is a custom built ESP32 with a Hall effect sensor, literally attached and hot glued into the dial on the top of my 250-gallon propane tank. That guy updates, I want to say once a day, just because I only use it for cooking, so that propane usage is pretty flat otherwise. But nevertheless, it's there and it's accurate. It is calibrated fully for the entire scale of that gauge. And jumping down to irrigation, there's about 4 different irrigation controllers here throughout the yard. They're all scheduled through Home Assistant. There is a North System Master. There's a couple drip systems, but they're all ESP32 with relay boards, all custom built. What I do is I take a 24-volt transformer that you need to drive the valves. I'll run that through a buck converter, flipping that to 5 volts DC. I'll use that to power the ESP and the relay board, and then I'll shoot the 24 back out and use that through the relays to actually control the sprinkler zone valve. So again, on each one of these things, I'll put together a quick YouTube short with a little bit more in-detail view of what it is, what the actual hardware looks like, and what the build looked like. Anyway, I hope you enjoyed this, and I hope it encourages you to do something very similar for yourself. Thanks. We'll see you next time.